Welcome back to another episode of JavaScript Jabber. This week on our panel we have Dan Shapir.
Hello from a freezing wintry Tel Aviv, 60 degrees Fahrenheit.
Thank you for rubbing that in.
I know, I think it's below freezing here. We also have Steve Edwards.
Yo, yo, yo. Coming at you from a slightly warmer now, Oregon, where we really need snow.
Yeah. Also, Steve, word is that you are currently looking for a Laravel Vue job.
Yes, something along those lines would be nice.
All right. So if you want to hire a Steve, get a hold of him.
This particular Steve would be nice.
That's right. Do you want to put like contact information out there?
Yeah, I was going to wait till shameless plugs at the end, but yeah, you can, my info's on my GitHub at Wonder95. Same handle for Twitter. Those are probably the best ways to get hold of Steve at smgaweb.com.
Cool. I just want to make sure that, yeah, people hear it and they can reach you if they need to. I'm Charles Max Wood from Top End Devs. And this week we have a special guest. We have Matteo Collina.
Hello. Hi, folks. Hey. Hi from Forlì, Italy. It's been a rainy day here, and I'm staying at home.
I didn't know you lived in Forlì.
I live in Forlì.
Oh, I've been to Forlì.
Really? Like, not many people even know that is where it's on the map.
Yeah, ho passato 2 anni in Italia. I was a missionary in Italy, and yeah, so I've been to Forlì and Rimini, and
wow,
I lived in Ancona for like 6 months. So yeah.
Wow. Oh, so you know. Nice.
And we, my wife and I, passed really close by just when Matteo happened to be in London.
Yes.
So we unfortunately kind of missed each other.
That has been a massive wreck, but my calendar these days during conference season is close to a nightmare.
Well, all I can say is we'll probably be in Italy again because we love Italy. And next time, hopefully, we'll be able to actually meet.
Hey.
Yeah, I would love to go back. We had a foreign exchange student who also lives in Ancona, and so we'd like to see her and her baby. So anyway, what are we talking about that's not travel, tech, or Steve needs a job?
Today we're talking a little bit about the latest thing in Platformatic, my company, and Node.js, I think. Maybe with some AI spiced in it because, you know, everything is AI today.
Yeah, a lot of our listeners may not be familiar with Platformatic, but I think that if you're doing anything with Node, there's a good chance that you're probably using at least one thing from Platformatic. Like I think
it's absolute. Like at this point, I think you're using something from Platformatic, close to 100%. Okay, it's as I say, last year I touched 42 billion downloads on NPM, some impossible numbers like that. So this is the state.
So like every man, woman, and child on this planet is downloading stuff from Platformatic like 10 times a year.
I have no idea. Like at this point, it's everywhere. As I say, I am in everybody dependency tree. So I am the Nebraska man. I'm joking. Okay.
I thought it was just your mom over there npm install Platformatic stuff.
Look, that can be possible. You know, I fixed their laptop for Christmas, so that was the gift.
There you go.
So it's the one time over a year that somebody can ask me to fix their computer over Christmas.
Holiday tech support, is that it?
It's something that everybody does. So
it's so true.
Talking about things, we have since the last time I was here. So what we have released a few benchmarks, okay, that I think are pretty relevant for everybody to look at. So let me just get them, and so that we can discuss them. So I'm going to pass them.
While you do, I want to emphasize that while I was obviously somewhat kidding before, it is absolutely true that I kind of consider you to be sort of Mr. Node.js, especially now that Ryan Dahl has moved on to other things.
it's well, I have been since this summer. I've been nominated the chair of the Node.js project. So
Wow.
I am effectively running the thing.
Wow, I didn't even
So
know that. Wow, that's pretty
it's
amazing.
it's an honor. Let's put it this way. It's an honor.
Yeah, we talked about it slightly before we started the show officially that Node is not new, obviously. It's been around for a while, but I'm seeing Node usage actually increasing. A lot of organizations that have previously been using other technologies for the backend are adopting Node as their go-to technology for backend stuff. I don't know if it's because of the Lambda functions and stuff like that, or it's because, all the meta frameworks out there, Next.js and 10stack and whatnot. I don't know. Maybe it's like everything together, but I'm definitely seeing Node.js technology usage pick up. A lot of companies, like I was speaking at this conference in Israel, and like every company that I was talking to was doing something with Node.js on the back end.
Yeah, it's everywhere. Okay. Right now, if you want to build anything for the web, you're using Node. If you're not using Node, you are probably on a minority. And it might be good to be in a minority, but the mainstream stack right now is something React-based plus Node.js on the server. And
I'm in the minority.
Me too.
I know, but you probably are using Vue, I've heard. Okay.
Vue
So
and Laravel. I'm a Laravel guy in the
Yeah.
backend. So.
I would wonder. Okay, this is sorry. How do you do server-side rendering with Vue on Laravel?
If you use Inertia.js, which is something I'm a big fan of and have talked about ad nauseum probably. On here, Inertia has a server-side rendering capability. If you're using Vue with something like Nuxt, it also has server-side rendering capabilities.
Yeah, but then it's Node.
Right, correct. Okay. Point taken. Well, you asked how to do it with Vue, so that's how.
No, but it's sorry. With Nox is Node.
Yes.
So is the inertia not not JavaScript running somewhere?
Inertia is basically a glue layer between your front and your back end that allows you to plug and play. So you could use Vue with Ruby, with Laravel, with Node. You could use Vue, Svelte, React, Angular on the front end, and you could use Laravel, Node, Ruby on the back end in any combination. So it's crazy fast. I have an application that I've built and maintained for a while, and it's just amazing how fast it is. It basically sort of hijacks the post request, and the browser doesn't do a full reload. It passes some headers that tell it, hey, don't do a full reload. It communicates between the two. Point being, to answer your question, if you go with Inertia, there's server-side rendering capability. So if I want to do it with Laravel and Vue, then I can do that.
Like I am seeing, okay, to be clear, I'm looking, I opened it up in a second and it's showing me some Node.js code.
It's possible. I haven't used it yet.
It's the way to do this kind of things typically is there is some little Node.js thing running, doing the job. I don't know. Somewhere, okay? Yeah. Because the problem is that with modern front-end frameworks, they are isomorphic. So you have the same JavaScript code that runs on the front end and on the back end. And in order to do server-side rendering, you have to render it on the back. Okay. So
you need a JavaScript runtime on the back end.
And you need a JavaScript runtime on the back. Okay. To do this.
So it's underneath. Yeah. Okay. I get you.
So this is why I'm saying this is the point of there is always some Node.js everywhere and then
Platformatic kind of flip the script there, where you kind of put WordPress and Laravel on top of Node or something.
Yeah. Yes. So last year we shipped a few experiments. We were able to run full PHP inside Node.js. It works really well. It's actually very performant, to be honest. So there is literally nothing stopped that kind of those kind of deployments. But it's let's see what the market says, and if there is if they are attractive for the market, we will keep pursuing those
Is it using
directions.
WASM or something?
No, binaries. It's the actual PHP runtime from the operating system. It's the same thing. It's the same hooks that Apache uses.
Okay, now I understand what you're doing. That's interesting.
So we were talking about benchmarking. How does this tie back in?
Yay. So we've been doing, this is the benchmarks, okay? We've done a few. I just wanted to point out two. One is, and let's see where the chat is here. What is it? Is there a chat?
Yeah, there's a chat. It's on the right. It's got a little chat bubble.
Okay, here we go. I'm pasting in the chat. So this is one. I am pasting it. The second one that we have done. And then I have a few more to talk about. So the first one is we've done last year. It's a benchmark showing Next.js performance, okay, under very high traffic. So for Next.js. So what is happening is we have done a lot of tests, okay, and it's with a lot of tests. For example, with 1,000 requests per second for a couple of minutes on against Next.js, and those were hitting essentially saturation. This was a hello world page, okay. It's very normal for your system to go to, if you're using Next or a React-based server-side system, to go between 8 and 20, maybe 50 requests per second at best. Okay, if you have a very complex system, like it's slow. Okay, in the genetic term of thing. Okay, so the critical point, okay, of this was the success rate, but more importantly, the latency. Okay, the latency for this kind of system is very bad. Okay, and this is affecting a lot of companies out there. Okay, and a good chunk of that problem is due to how scheduling is done of multiple pods in Kubernetes. Okay. Round robin, unfortunately, it's not the best algorithm most of the time, okay, but that's the one we have. And last but not least, there is the problem of event loop blocking. Okay? Event loop blocking is critical. So if the event loop blocks, then the system becomes unresponsive after this. So it's problematic.
But isn't the whole thing about Node that every event loop is kind of never supposed to be blocked?
Well, tell that to all the developers using React. Like absolutely, that's the whole point.
That's the idea. Yeah.
That's the idea. But React server-side rendering is super expensive. Okay. And it's super expensive. So
yeah, a lot of string operations and stuff.
No, it's a massive. So basically, what React does, it creates a full virtual DOM of all the elements in the page, and then it stringifies that, and you need to walk through a massive tree for every request. So these create a massive pressure on the GC as well as the computational cost of allocating of stringifying all of those elements.
That's really unfortunate, given that it then immediately discards that entire virtual DOM.
Exactly. You know why I've been a critic? Like the only framework that does better is Solid. I think is significantly better on the topic. Okay.
Maybe because it doesn't have a virtual DOM.
This is a good point. This is actually a good point. Okay. And yeah, so the whole point of Node is not blocking the event loop. And I can really subscribe to that sentence. Okay. So to the point, to the point that if the event loop blocks for a long time, it's better to kill that node process and start a fresh one up, because keeping that running is useless.
Yeah, if you're going to be doing really significant GC, then why? I mean, just, I'm reminded of what Apache, I think, their approach was about like managing like the heap in like sort of chunks and then discarding the entire chunk rather than trying to do fine-grained GC.
Well, it's it, to some extent is relatively similar what we are doing. So with what our Node.js application server, we based on this thing, we can monitor the state of the event loop from the outside, and if we detect it is totally blocked, nothing comes through, nothing is going to come through. We just shut the thing down. So, and because we shut the thing down and restart it we can essentially recover a really broken pod back to life and let some traffic pass through.
So the basic idea is saying, instead of trying to do this really complex GCs at a high frequency because of all the incoming requests, every once in a while just kill the pod and start fresh.
Well, it's when the event loop is blocked. So it's literally like when there are too many, like the problem is also that there are all those requests are piling up to be processed. And after 5 seconds, it's no point. There's no point in processing them. You should just abort them.
And it's because of the GC, because of the virtual DOM?
It's all of both of them. It's a very CPU intensive operation, especially with a lot of.
Interesting. You would think that they would have figured out a way to offload it to workers or something.
Which is what we did.
Is that a different thing or the
No,
thing?
so basically with what we can have multiple workers listening to the same socket so that you can do the load balancing easier. It's very similar to similar to Node Cluster or PM2 and Node Cluster, but instead of doing the load balancing inside Node.js, which is what Node Cluster and PM2 do, in that we use a new node feature that let us do load balancing inside the kernel using a flag called so_reuse port, which is significantly faster.
Can you elaborate a little bit about what actually is? Because
it's an application server for Node.js. You can just give it your app. It will run it inside a worker thread, and the main thread will just monitor it. And you can scale it up and down, multiple threads, multiple cores. And if you want, you can even have a heterogeneous system. You can have multiple different applications running there, and they can communicate via message passing or just HTTP over memory.
Interesting.
So what does it compete with? What are the, like, when would I use what, and would I put like Next.js on top of what?
If you're deploying Node.js in Kubernetes, you're probably not doing the right thing if you're not doing it today.
Using what?
Yes.
What does it stand for, by the way?
What? Come on. What can what be? Can what be? Come on.
How do you exactly spell it?
WATT. It's an honor to over James Watt.
Ah, okay.
Yeah.
The power.
Yeah.
So we needed a name. So on NPM is Watt PM.
Oh, now I see it in your blog post.
Yes.
So whenever I use Node in Kubernetes, you recommend using it on top of what?
I would say yes. It gives you more reliability. In this example with Next.js that I've shared in the chat, essentially we can move down P95 from a second to 235 milliseconds.
Oh, wow. And just for those who don't follow along with benchmark stuff, a P95 is 95% of your requests take this long or less. So in other words,
It's beneficial for the 5% slowest users.
It's beneficial for everybody, to be honest.
It's for everybody. Yeah, essentially, yeah. So all the requests now, so 95% of the requests, instead of taking up to a second, now take up to 235 milliseconds. Now you assume that the other 5% it also speeds up for, but yeah, that's kind of the measure, and it's one of the more common ways of measuring how fast your application is, because the load and the requests and what it has to do and what else is running on the machine can vary from time to time. And so this kind of averages it out.
Also, think about it from the perspective of a business. A lot of you want to think about the customers that have it the worst.
Yes.
And you can't really afford to lose 5 or 10% of your business because it's just too slow.
Exactly.
But I'm thinking about what you said. It does mean, though, that you want to allocate more than one CPU per
Yes.
node instance in your Kubernetes in how you divide the pod.
Absolutely. This actually helps. Okay, let me explain why it helps. Okay, the cost of spinning up a new pod in Kubernetes is more or less fixed, independent of the amount of resources that are attached. Okay, or anyway, it's not very much different. Okay, if I am scheduling largest things, each unit of scale gives me more power to handle my spikes better. So it's the edges of scaling are a little bit steeper, but this actually helps smooth the curve way quicker because these new things make it can handle more load per unit. Okay, so this is one thing. Okay, the second thing is Kubernetes takes minutes to scale. So when there is load, typically it reacts in 1-2 minutes. Is very slow. Okay, to schedule things up, and by having this system, you can actually absorb the shock completely inside your pods.
Interesting. Very interesting. I need to think about this some more. I will definitely make sure that our DevOps people see this. I mean, literally everybody is using Kubernetes these days, whether they need to or not.
Exactly. We also have built, but it's not mentioned in this benchmark, built another product called Intelligent Command Center that is open source as well, that reduce the decision time of Kubernetes from minutes to seconds. So the pod starting is making less than 5 seconds, the decision to start a new pod.
Doesn't that make the system kind of more noisy?
Yes, to some part, no to the other, because it's actually very fast in scaling up, okay? But it can scale up on very specific signals from the app. So it can be a little bit more noisy, but it actually allows you to reduce your baseline of instance significantly. So
because you can scale up when you need to.
You can scale up way quicker when you need to. So you can reduce your baseline, and during off-peak hours, you can actually save a lot of.
Yeah, I guess that's always the thing that I'm concerned with when you have this kind of automation is, does it scale up too much? Does it handle things when I need it to scale down? Because yeah, it costs a lot more when you scale way up. But if that's what you're getting in traffic, and usually traffic translates in some ways to money, not always, but yeah. So that anyway.
Pretty cool. So this was part of our results. We published this study, okay, and hopefully we can get some results from our actual customer out soon. But this is our own, and all the benchmark and harness done for this is open source, so you can check it out and run it yourself if you're interested.
This should be making a lot more noise than it is, I think. I was kind of aware of this, but I was not fully aware of this. And like I said, literally everybody is doing Node on Kubernetes these days. So if the impact is so dramatic and so significant and so readily achievable,
yes,
there's literally no reason not to try it out.
This is partially the reason why when you asked to come to join the show, I said, I'm coming to join the show. This is research that we published. We published late last year, I think. And it's pretty solid, I would say. Then we have done another article, okay, a more spicy one, if a more spicy one, I would say, okay. And we benchmarked on the same benchmark of the first one, slightly different traffic load, whatever, okay. We benchmarked the three Node.js runtimes in Kubernetes. So Ban, Dino, and Node.js, as well as our own way of scheduling things with WAP. So we got some really unexpected results. Not the results that I would expect. And it showed that Ban...
So just before you tell what you found, just to clarify, what is only for Node? It's not for the other the other platforms. You can't use it with Dino or with Bun.
No, you can't. Well, you can't because those other platforms are not fully Node.js compatible. The approach that we have taken with Watt is instead of creating a custom-built Node.js runtime with our patches, we have upstream all our patches up to Node Core of the things that we needed. And that is written mostly in JavaScript, mostly. Every now and then we had to have a little bit of C++ to implement some feature for old Node.js versions that are not being released yet. So if we need a feature, we need to extend support for it. But it's right now, I think, is all JavaScript. So,
I have to say, before you go too much further, that I like this idea of, hey, we needed this in Node in order to make Watt work. And so you contribute it back. And so it's stuff that other people can use.
Exactly. Oh, 100%. Like, this is the whole point. Like, part of the reason why I funded Platformatic was, can I try to build a business that can make this open source economically viable and allow us to grow with it? So let's try. This is my try. Okay, I might succeed, might not succeed. I hope I succeed, but I needed to try this. So this was part of my journey.
I'm going to go into a tangent here real quick because I'm kind of curious. So when you say make the open source economically viable, what do you mean? Like what
the fundamental
open source?
The fundamental point is there is a substantial lack of investment in core technologies from companies, and we need more companies that invest significant amount of money into the commons. In order to do so, we need them to be to be good businesses so they can contribute back and up. Okay, and you cannot rely on the sponsor model because it's too little, too late. So you need, if you need to do payroll, you need to have significant sales involved. So the goal is to build a significantly big enough company that can afford multiple people working full time on the core technologies.
And
not because it's a good thing to do, but because it needs them to be there as a core function of the business, so that it's not a donation, it's a function. And and because it's a function and is a core part of it, it will not stop.
And what is that company selling then?
That was what I was. Yeah.
So our current business model, after several pivot iterations and stuff, we sell enterprise version of all our technologies plus support and onboarding. So if somebody needs anything related to Node.js, we can provide support. We can provide and we can provide an enterprise license for our core technologies and include.
What does an enterprise license mean?
This is an answer for a question from my co-founder. Okay. So there is for the Intelligent Command Center, there is a premium version with added features. For example, like more audit controls, logins, these kind of things so far, but it will grow more. It's more related to SLAs and response to incidents and being available than like other things.
So it's more on the support side than the feature side?
It's the feature side is more on all these technology are moving dynamically. So the our customers can steer the wheel and help us decide where we go next and what they need, what features are missing, and they're partners.
I think that SLAs are the way to go, to be honest.
To be honest, I would say they sell very well.
Because like literally, if I'm running my backend on Node, I need SLAs, and if if I can kind of guarantee it by licensing your services, then it's no brainer.
That's what it is. So anyway, that's exactly the point.
Cool. So now let's go back to where we were before we went on the tangent, if we can remember where that was.
Yeah, look, we can go on the tangent all the time. So anyway, we are, I was chatting, I've over the break, I've done this extensive benchmark on Bun, Dino, and Node, okay? And I got very surprising results. The benchmarks included running the same Next.js application that we talked about before, okay? React server-side rendering, heavy on memory, heavy on CPU, really like possibly the worst load, but also the most common load that you can have running on Node.js these days. And I got very surprising result that I didn't expect them to be. So specifically, I got P99 of 74 milliseconds for Bun, 1.3.5. They did new version, so
approximately 1 second.
Yes. While Node.js was 174, Dino at 100, and Node.js with VAT at 115.
So Bun was noticeably slower than everybody else.
Exactly.
To be honest, I know that Bun has a reputation for being fast, but people need to understand that fast can mean different things in different situations.
Exactly that.
Well, I hear people tout other things about Bun too, but yeah, you run a different application. The different engines manage memory differently and concurrency differently, and then other things differently, and so yeah,
it's beyond a different application. I think it's like a different scenario.
Yes,
because you've got startup times, and you've got runtimes, and there's a question of when optimizations kick in, if they kick in. What do you do in the JIT stage? Stuff like that. So what could be really fast for a long-running node type service could be really slow when you're building a utility that just runs, does something, and then terminates. And an expectation that a certain platform will do everything better is, well, it's happened before, but it's not always realistic.
It's so a few notes, okay? After chatting with a few people, they gave me this informal feedback. You can take it with a grain of salt. JSC, which is the JavaScript runtime behind Bun and Safari, is optimized for cold starts to start very immediately. Imagine when you open Safari on your iPhone, it opens up super quick, okay? While V8 is more optimized for long-running application. Think Gmail.
Yeah, that's the thing. People talk about like the various. There's this been trend of rewriting the JavaScript utility ecosystem in other programming languages, be it Go or be it Rust or be it whatever, instead of doing it in JavaScript or TypeScript. And you kind of hit your head on the nail there, Matteo, because, for example, if we think
Hey,
about...
Dan, that's nail on the head, not head on the nail, unless you really want to hit your head on the nail.
Oh, is that what I said?
Yeah.
Okay.
Just thought I'd point that
Sounds
out.
painful.
Well,
Very
you know,
painful.
Hebrew, we write right to left, so it's...
Well, boy, I mean, gives new meaning to the term hammerhead, doesn't it?
Yeah. Anyway, what I was saying is that the JavaScript optimizer in V8, I always forget the name. What is it? Turbofan or whatever?
Turbofan. We also have maglev now, but this is...
Yeah, it's basically based on identifying hot code and then optimizing that while the code is actually executing. But in order to identify hot code, the application needs to be running for a while. And if you're running a tool that just starts up, does its job, and then finishes, you'll never get to that optimization stage.
Exactly.
Which is
exactly.
kind of
but if you run long enough, you get into that optimization state.
Which is kind of my concern, by the way, with some Lambda function usage.
Well, let me say this. If you are moving serious traffic, you are probably better served using ECS or Kubernetes or whatever long-running process. But to be honest, Lambda actually, okay, let's open the Lambda point, because it's actually a validation of that to some extent. So if you have followed what has been launched by AWS at the latest reInvent in December, is a new Lambda runtime for high throughput scenario, high traffic scenario that is not actually one request per process, okay, but it allows one process, look at this, to have as many threads as it wants to handle requests. In a lot of things is actually similar to how that works internally in how the things are scheduled. So this kind of system allows Lambda to use all the potential of Node.js essentially, and actually leverage these long-running optimizations that we talked about.
Interesting.
So it's actually a very interesting model, and a lot of people are not, tapped into this yet. Like they think, oh, Node.js is single-threaded, or mostly single-threaded, while in reality it's not, and you can do a lot of interesting things with it. And they just, ignore the point.
Well, to be honest, JavaScript is a single-threaded language, but Node and the JavaScript virtual machine has never really been single-threaded.
So it's exactly so.
For those of you who don't know, for example, the V8 GC actually runs off of the main thread to a significant extent.
Yeah. Well,
Wow.
It has been, not at the beginning.
Not in the beginning. I'm talking about currently.
Yeah. It's off it. So anyway, I just wanted to say we got these incredible results. Like, not expected, to be honest. I didn't, I had to check them 5 times and have some friends check them with me.
Why? So why was it unexpected? You didn't expect such a bun to be that slow in that particular test?
Yes.
And did you expect Dino to be that fast, by the way?
Yes, significantly. I was expecting Dino to have those kind of numbers.
I think that's a scenario that they've been optimizing for, right?
No. It's the way. So their Dino event loop is based on Tokyo, while Node event loop is based on libuv. Okay, and Tokyo is maybe a decade later than libuv type of thing. And things have improved in how you do those kind of things. Okay, and it's very hard to chase something like libuv.
Understood.
So that is the problem. Like it's not just libuv, by the way. It's also the Node machinery in entirety. So how we get the data out of libuv, how we schedule new connections, how we do there's a lot of work over there and a lot of overhead. But some of that overhead is essentially legacy, and it's very hard for us to, it would be possible to optimize, but it's a hell of a lot harder.
So could you remind me again what the numbers are for Node versus Node with what?
So on P99, we had 174 milliseconds. We measured 174 milliseconds with Node, and with VAT, 115.
115, that's a
Yep.
115.
Yep. 174 versus 115.
So we're talking about close to about 30% reduction, 40% reduction, something like that.
Yeah.
So that's significant.
I know.
And
More or
that's,
less, Dino, VAT and Dino are very close.
and that's the SSR scenario.
Yes.
By the way,
So I guess what I'm wondering is so for the people watching at home, right? This you're throwing out numbers and scenarios, but what does this look like for me, right? So I have a Next.js setup, or I have a Node application that I've written, and I've got React on the front end, and I've got server-side rendering set up, or whatever. Like, how does this actually translate, and what does this look like when I'm troubleshooting or measuring my own benchmarks or things like that?
So the key difference is the point of so when you do it's in your app is when you do saturation or stress testing. Okay, so you are putting it to a very high load scenario. Okay, and you want to know when your app breaks. And essentially, these numbers create more or less a ranking of where your application stay responsive and is usable by the end user, okay, in those scenarios.
I'll give another way to look at it. You're doing SSR to improve application startup times.
Yes,
right.
That's a primary motivation of doing SSR. And what we've literally learned now is that you might be doing SSR with the goal of improving startup time and end up, pardon my French, screwing yourself. Because your backend will not be able to properly handle the extra load. And I'm actually looking at the Crux data. We've spoken about it on the show on several occasions. So just a quick reminder what it is. Google collects anonymous performance information from all browser sessions or Chrome browser sessions, and unless you opt out, and it's not really easy to opt out, so assume it's more or less everybody. And they are looking, and then they are breaking it down by technologies used using the HTTP archive. So basically, for each domain, they're looking if a domain has sufficient amount of traffic. So they're looking at the top 10 million domains, more or less, in terms of traffic. They're segmenting them by technologies used, and then they actually release this information to the world, so you can actually see which technology is more likely to give you better performance. And I'm currently looking at the graph that compares all the websites within Crux, the WordPress websites, the Wix websites, and Next.js websites. And I'm looking at what percentile of websites get good performance results according to Google. It's the Core Web Vitals, okay?
Wow, yeah.
And if we're talking about all technologies, we're talking about 51%. So approximately half of websites get good Core Web Vitals, and about half get poor Web Vitals. If we're talking about WordPress, the number is 46%. So WordPress is slightly lower than all technologies at large, but pretty close. So WordPress and all technologies is more or less the same. Maybe also the fact that like half the web runs on WordPress. Wix currently is at 73%. So,
what is this website? It's the Crux dataset, right?
Yes, I can send you, I'll put the link in the chat.
Yeah, perfect. No, keep going. Fantastic, I found it. Okay.
So Wix has 73%. So if you're building a website on Wix, there's a 73% probability that you'll be getting good performance. Okay? What's the number? Sorry, what's the number for Next.js? Now you assume that Next.js would be great because the whole thing about Next.js is that it's SSR'd. So what's the probability for Next.js? Can you guess?
Feel like you're setting me up to let me down. And so, well, I would have assumed before you said it kind of skeptically that it'd be somewhere around Wix, 60, 70%, but you're making it sound like it's probably like 30%.
Exactly. It's 29%. So the probability of getting good performance when you're using Next.js, you're putting all this effort into building. Let's say AI is not doing your entire job yet. You're putting all this effort in coding your website in React and hosting it and whatever, and your probability of getting good core web vitals is less than 30%, and that's really unfortunate.
Yeah, that's bad. So the stuff that Matteo is talking about, then do you get those kinds of performance increases kind of for free just by upgrading your node, or how do you make it better?
Yes,
by using what
on top of Next, which just works. So it's not.
And I can do it on Vercel?
No, Vercel runs on its own thing. So the fundamental point is Next.js is designed to run well on Vercel. Okay. And to run it well on your own infrastructure, you're missing a few components. And we added those few components.
So with Vercel out of the box, I'd be getting comparable performance to what?
I have absolutely no idea. I've not measured, I've not benchmarked their cloud. To be honest, I don't even... it's a good product. I am a customer, like Platformatic is a customer of Vercel. Okay? We are a small startup. It's the greatest thing ever to be using Vercel. Okay.
It's easy.
It's easy. There are a lot of companies out there that cannot use Vercel for all sorts of reasons. Okay. And that is critical.
I know that a lot of companies are running Next.js on top of Amazon AWS.
Yeah, exactly. So this is what I'm saying. Okay. They are running those things, and there is even a thing called OpenNext to run it on top of Cloudflare and other stuff. Okay, what we've done, make it run very well on top of Kubernetes.
By the way, I'm curious, what's your opinion of Nest.js?
You are asking me tough question, Dan. I am not. I am. I do have opinion. I have one opinion.
Nest is the backend framework specifically, isn't it?
Nest is like Node for Java developers.
I have a problem with it. Okay, the problem I have with Nest is its reliance on the old TypeScript decorators. So I don't know if you have been following the story of JavaScript decorators with TC39.
That standard that never, ever materializes. It's been stuck in stage 2.5, like forever. Or what?
Exactly. So the problem is that...
Just you know what? Before you do, let's just clarify that all our listeners... I kind of assumed that all our listeners were familiar with Kubernetes, which might have been either correct or incorrect, an assumption to make, but let's not assume the same for decorators. Decorators are a language feature in JavaScript or TypeScript, which allow you to decorate classes and methods and properties. You put the @ sign and then some words, and basically it wraps the declaration in a function call. And that function call can modify the actual class definition or the method definition. So for example, let's say the canonical example is I want to print out a log whenever a method enters and exits. Instead of explicitly heading a log everywhere, I can decorate the class maybe, and then it basically modifies the behavior of all the class methods. And whenever I instantiate an instance, I get this functionality automatically. So it's a way of implementing cross-cutting concerns.
Yes, it has two problems though. Okay.
Just to finish, it's been a part. It's very popular in Angular. It's been part of TypeScript for a while. And there's a proposal to add it to the JavaScript language itself, which, like we said, is kind of stuck in purgatory.
Yes. Okay. Let me explain the situation there. Okay. So the current, so this spec, as it was originally proposed and done in TypeScript, okay, all TypeScript 4 and something, okay, and before, was very hard to polyfill, okay. If you look at the JavaScript code that is being those syntax transpiles to, you can get very scared, okay.
Like a sync await?
It's like regenerator style things. I don't know if you have ever looked at under the cover of what regenerator does, but it's pretty ugly, okay? Because there is a lot of global state, there is a lot of things happening. It's not nice. Then the standard changed in a way that it's essentially function wrappers, okay? Which can be attached to classes, because classes are functions, okay, or functions, okay, which makes it way easier to reason about this thing, okay, and also it's just a function, so it literally is easier to, implement to some extent.
It's a function that gets called with a function as its argument and a context, and then it returns a function that gets used instead of the original function.
Exactly. Very straightforward. Okay.
I was just thinking, yeah, it sounds like I'm still not sure I follow. Anyway,
it's simple, but there is a difference. Okay, the old standard allowed to attach decorator to arguments parameters.
Yeah, Next.js uses that a lot.
Exactly, and in the new standard, this is not possible anymore.
Because they're not functions, they're just parameters.
Exactly. And that is my whole problem. Okay.
That Nest.js is tied to a syntax which goes against the grain of where JavaScript is heading?
Exactly. Also, it transpiled is really bad. That syntax. I care a lot about the JavaScript that is being executed, and that is transpiled to some really to things that I would not have running on my servers.
I'll say it again. It's really popular with people that come to Node from Java Swing.
Absolutely.
So I know a lot of backend developers that literally swear by it. It's a backend that you use as a backend for API calls.
Yes.
It's not about SSR or anything like that.
Exactly. But I have a side on all of this, so you can take all of what I said with a grain of salt. I've built Fastify to solve this problem, been using it for the last decade, and very happy with it.
Yeah, it's really opinionated. Anyway, but in terms of performance, what can you say about Nest.js?
I have not benchmarked it significantly, okay? I suspect is slower than Core Express or Fastify. You can use Express or Fastify underneath, and I suspect is slower, and it adds a little bit of overhead on top.
Yeah, it has to, kind of, because it's literally built on top of it, so.
Yes. I hope is as little as possible. But look, you're asking, so you might get an article on it. So my co-founder is telling me to do it, so to do the research. So I'll do the research.
I can say that it's pretty popular. It's popular to the extent that it's boring. Like the best compliment you can give about the technology is that it's boring.
Yeah, I know. I do the same.
Okay, so moving back to what we were talking about so you talked about the surprising results that you got. Now, so obviously, if I'm running, the bottom line is that if I'm running currently Node on Amazon, and especially if I'm using it for SSR, not necessarily, but especially if I'm using it for SSR, then I should be looking at what? Because bun won't save me.
Pretty much.
And okay, cool. Anything else to add on that particular topic?
Nope. I think I covered it all.
So you had a list. Let's go to the next one.
Yay!
So just on the issue of time, we have been recording for about an hour.
Which
I'm totally fine sticking around for however long, but
I need to probably go at when this meeting ends that I have on my calendar.
So it just means
So you
that we
got
need
20
to bring
minutes.
it on and bring you on again.
Yeah.
Absolutely. I'm coming again. Of course. Okay, so the second one that I wanted to cover is the topic of flame graphs. Now, in all of this benchmarking, I had to do a lot of optimizations and look at things, okay? And we created a brand new flame graph tool to do performance analysis. Okay.
I don't know what a flame graph is.
So imagine that you are you want to do a performance optimization. Okay, you have you know your application is low, and you want to know where it's low. Okay, a flame graph shows you the hottest points in your code base that consume the most time.
Okay, I've seen them. I just didn't know that's what they were called.
Exactly. Okay.
So I've seen them in Grafana and in New Relic. So
yeah, you can click a button and get the flame graph. The key point here is the flame graph abstracts time. So it takes an interval of time and says, let me represent the function calls that happen in this interval of time. Okay. Because in that way, I know how much a function has been called compared to the others, so I can make a comparison. Okay. So I can, so we can detect how much a function was called and how hot it is. Okay. But I've been doing this for a long time. I created the second kind of tool, third generation tool that I create with these kind of things. Okay. A new version of Node require different tools to get it done. Finger crossed is the last, but probably there will be another one in a few years. Okay.
Now, somebody who's listening to us and hears a flame graph to measure node performance might be thinking, hey, why do I need this from Platformatic where I have it built into DevTools for like forever? Why do I need yet another one? What's wrong with the one that's built into DevTools?
DevTools gives you a flame chart, not a flame graph. It's not as readable. It doesn't give you the full picture. Also, it's the part of the problem is the collection of that data is very expensive. So by running it in DevTools, you are essentially altering, like the act of observing something modifies the behavior.
Otherwise known as quantum mechanics, right?
Yeah,
it's quantum mechanics at play. Yes.
Just to clarify, I'm aware of the issues, and I totally agree with you. I'm just bringing it up so you can rebut it.
Perfect. Okay, so it's quantum mechanics at work. You observe it, you change it. Okay. The way what we have done, okay, instead of relying on the inspector to get that data, okay, we are using a C++ module from our good friends at Datadog that they use in their agent to collect those data from C++ straight out of V8 in the fastest possible way. So it does not interfere much with the application itself, to the point that you can use it in production to collect those flame graphs. Now, if you try to enable the inspector, you are looking at a 50% performance drop.
It's beyond that. First of all, let's start with the fact that you probably don't want to attach a development tool to your production environment.
Yes.
Somebody might click pause.
Yeah.
You're not going to be running in production, a node server in production with -- inspect, you know.
Yeah.
At least not intentionally.
Yeah, and you're not and you're not going to leave that port open. Well, you know, you can do SSH tunneling and whatnot, but anyway. And like Matteo said, the overhead of actually doing a flame chart is really high. And by the way, also for that same reason, it's time constrained. You can't run it forever. You can run it for a very limited amount of time. Now, I have in the past implemented certain scenarios in certain applications where we sent a signal or an event into a process to kind of trigger it. But it's you can only run these sort of things for a really limited amount of time.
Exactly. You can also still run this kind of tool for a limited amount of time. You can even, the way you do it, you run it for essentially 1 minute to collect what's happening. And in our platform, we can even start collecting it when usage goes over a certain threshold, so that you're not wasting money. But it's actually very good. So you can actually even run it in production, get good data out. Datadog is running this in production all the time. It's fantastic.
By the way, I have to say it was really funny. So when I found out about this tool and I started using it and I started experimenting with it, and I reported like 6 issues or something like that back to Matteo and the guys and the gang. And like within 1 day, it fixed all of them. It was really amusing.
Yeah, we're fast. It's so there is that. Okay, tool was great. Last week, I think we shipped something new. We shipped a way to get a representation of the flame graph as Markdown. So you can essentially feed it to an LLM and it will just fix things.
So it will basically understand where your bottlenecks are in terms of performance and focus on them automatically.
Exactly.
Like this function is slow, but it's not just slow, it's impacting, it's being called a lot, so it has a significant impact, or that function is hardly used, there's no point in optimizing.
Exactly.
That's but
really
like
cool.
You said, Matteo, it seems also that some of the fixes are pretty commonly understood and easy for the LLM to implement. And so I could also, it's like add a database index, or, hey, if you do it this way instead of that way, this structure is more performant than that one. And, it's little changes, but they're low risk.
Low risk, and the LLM is great at it. Okay.
Yeah.
What I call the low hanging fruits. Okay. So the low hanging fruits are super easy to do for the LLMs. Okay. Now, from the flame graph, you can even spot some bad architectural patterns happening, and the bad architectural patterns are harder to figure out. So during my research, I opened a few bugs. Okay. One is on React Router. I found that it for every rendering, it schedules a timer that's never cleared, so it runs to completion. It's like 5 seconds, but that becomes a hotspot for the garbage collection.
Right. Oh, I was going to say it's a memory leak, but yeah,
it's not.
GC does get it.
Eventually,
yes, but it's enough that it memory allocated for more, and it's enough for that memory to be moved to old space. So it's actually creating some problems for the runtime that's actually not needed. That could be avoided. Okay, I sent a patch. Another one that I found recently is a bug on with this tool is on GT. I don't know if you know GT. By the way, I found this a very horrible bug, and I am really bad. Let me pass it to you, because and GT is a module downloaded 60 million times per week, something like that.
What, GT?
Yeah, GT. This is a bug. I passed this bug in the chat.
JITI.
Yeah, it makes any function direct export in a function between 60 and 70 times slower.
What is GT?
It's a module to load TypeScript straight from Node, similar to what TS Node does, but that did differently. Some of things is used by ESLint, Nuxt, Nitro, PostCSS. I don't know. Tailwind. It's very popular in front end. I had no idea this even existed until it showed up in my flame graphs.
Man. Don't you love it when people use proxies?
Yes, you see, I have, It's one of the most misused technologies that you can get in now. Like if you're using a proxy, you should ask, am I doing it wrong?
And the answer would probably be yes.
Yes.
Not always, not 100% of the time, but you should definitely be able to justify yourself.
Yep. So I'm going to kind of push us to wrap up this particular topic because we only have like 8 minutes left.
So I just have to say that before we conclude on this, that the ability to gather performance information throughout the lifetime of a process in production is invaluable. You know, we've had similar technologies in other programming languages, like what's it called in Java? Java has their the Java black box sort of thing. I forget the name. That they have the ability to collect performance information usually without significantly impacting runtime performance. Like you can do it in production. The ability to do the same thing or similar thing for Node is really invaluable, and I'm really grateful for Matteo and everybody at Platformatic for releasing this game.
It's there. It's free. Try it out if you want. If you need, I talk a little bit about my company enough, but if you are using this tech and it's core part of what you do, you can reach out. We'll be very happy to help you.
Cool. All right. Well, I'm going to push us to picks. This is where we do shout outs about stuff we like. Yeah, I know that you're kind of under a time crunch, Matteo. Do you want to go first or do you want one of us to go first?
Oh, let you go first and then I go last.
Okay. Dan, what are your picks?
Okay, so I've got 2 picks. The first pick is we've been playing this amusing game in our family these past couple of weeks. It's called Hitster. It's this kind of game where you've got a certain deck of cards, and each card has this QR code that you scan, and it goes to with your phone, and it goes to and it actually starts playing that song. I think it uses Spotify, but I don't remember off the top of my head. And the idea is that you divide into teams, you play the song for about 20 seconds, and then the team whose turn it currently is needs to guess the artist, the title of the song, the artist, and the year in which it came out. If
Cool.
you need to guess at least 2 to get a point. If you guess all 3, you get 2 points. Something along these lines. And we've been playing this in our family, and it's songs from all eras. In the case of Israel, it's both Israeli music and international or American music or British music, and it's really a lot of fun. We enjoy it very, very much. And you listen to music, what's and try to guess the songs. It's a lot of fun. So that would be my first pick. And the second pick is actually Matteo. I want to mention that on X, Matteo, you put out videos on a fairly regular basis. They're relatively short usually. I think they're like 20 minutes each usually, about a variety of topics related to Node.js development, obviously, and they're uniformly excellent. And I highly recommend following Matteo and watching the videos that come out. So that would be my second pick. And those are my picks for today.
Awesome. Steve, what are your picks?
Before I get to the high point of every episode, which are the dad jokes of the week, an interesting video that popped up on YouTube last night by Jeffrey Ray, who is the owner and creator of Laracast, which, if you're not in the Laravel community, is a pretty well-known training platform for Laravel and on many, many other topics as well. And he titled it "I'm Done," and it's just sort of it's about 13, 14 minutes where he's just talking about the impact that AI has had on Laracast, and they just had to lay off a bunch of people, similar to what happened with Tailwind. the, sort of the use of AI in coding and, the pros and cons, and sort of almost having to use it or get left behind. He's I got to agree with him in a lot of what he says. It's only about 14 minutes, so it's a good watch, but it's I think it addresses the reality of AI and coding and how it's impacting things, both for the best.
I think
both for good and bad.
I think we should probably bring a bunch of open source creators, people like Matteo, like maybe we've had several Joel. We've had on the show talking about ESLint and TSLint, and basically talk about the impact that AI is having on open source developers. It's really cutting the branch that a lot of them are sitting on financially.
On that upriver note, I'll get to the dad jokes of the week. So first of all, pretty straightforward question here. What do you call a pony with a sore throat? A little horse. Right? So good. Thank you, Matteo. I love that. So everybody knows who Alan Turing is, right? The term Turing complete, in computer science.
Enigma.
And yeah, he cracked the Enigma codes in World War II. But nobody knows his sister Kay, who provided drinks, snacks, and sandwiches for him and his colleagues. As in catering.
Yeah.
Right. Took me a minute.
Yeah. And then finally, why does Spider-Man hate driving with his evil twin? Because he's a bad parallel parker. Oh. Thank you. Those are the dad jokes of the week.
I usually don't laugh at the dad jokes, but Matteo's reaction was priceless.
That's half the fun sometimes.
All right, I'm going to jump in with some picks. The first one, I always do a board game pick. And this one we got for Christmas. Man, has it been that long since I've been able to get on and record?
Yes.
Thanks, Steve. You made me feel better. Anyway, the game that one of the games we got was Everdell. Came out in 2018. My wife and I played it, so it was just two players with us. Probably took us an hour, maybe a little longer to play. We were learning it as we went, though. I think I played it with my sister and my wife another time, and it took us about the same amount of time because at that point we knew what we were doing. And anyway, what it is, it's actually, the board's kind of cool because it's got this tree that you kind of slide together. It's made out of cardboard, but it looks really cool when it's set up and it's sitting on the board. Reminds me a little bit of the tower in Fate of the Fellowship, which is a pandemic-like game based on Lord of the Rings. But anyway, so Everdell plays up to 4 players, and you're trying to collect resources in order to fulfill missions, and you're building a little town of animals in, basically in front of you, and that gives you special abilities. So it's a pretty standard kind of game. It's just, a couple of little nuances and stuff. Anyway, it was fun. Definitely enjoyed it. It's not so novel or different or whatever that I would just go and reach for it on my own on a regular basis, but I did enjoy it. It's definitely a game worth, having and playing. And the artwork on it is incredible. So I'm going to pick Everdell. Board game has a board game weight of 2.83, and that means that it's a fairly involved game. But if you've played a lot of the other resource gathering, deck building kind of games, it's nothing outside of the realm of what you've probably already played. So I'll pick that. And then what else? I started watching Landman, and I've been enjoying that. That's on Paramount Plus. And so I'm going to pick that. And then I watched My wife and I started watching the show, and she's a little bit sensitive to people dropping F-bombs during shows. And so if there's too much of that, she won't watch it. And so we watched like the first episode way back when of 11/22/63, which is there's this history teacher. His friend's been going back in time to try and save JFK from being assassinated. And so anyway, he takes all of his friend's research and, you know, all the preparation that he's done, and he goes back to save JFK. And then come back to the future where it's supposed to be better because, you know, Lyndon Johnson wouldn't have gotten us into the Vietnam War and a whole bunch of other things that other people did that, you know, this particular guy didn't like wouldn't have happened. And anyway, so I'm not going to spoil how it changes the future, even though the show's like 10 years old, just in case you want to go watch it. Because honestly, it's actually pretty... the whole journey's pretty interesting to watch them go through and, you know, encounter people from the past and stuff like that. So I'm going to pick.
So you've got Paramount Plus. How are you enjoying Star Trek Starfleet Academy?
I have not watched it at all. I've seen ads for it, but I haven't watched it. Is it good?
I've not watched it. I'm going based on the reactions and the critics. You know the story that they released the first episode for free on YouTube, and Nerdrotic, in competition with them, basically just put a video of a doll of Spock sitting on a chair, and he got more views.
Oh, funny. I have to say that
I understand it's Star Trek's Acolyte.
Okay. Yeah, I've liked a lot of stuff on Paramount Plus, but yeah, that's not one that I've been watching. We liked Star Trek Discovery and Star Trek Picard, but anyway, I haven't watched that one yet. So yeah, so Landman and 11/22/63, which I think was originally on Prime and is now on Netflix. Anyway, Teo, what are your picks?
So the first one is I've been tinkering a lot with AI things, okay, as everybody, and I am having a lot of fun these last few days on a project called Pi. It's a little open source coding agent that is highly customizable. It's the heart of Maltbot now, CloudBot, whatever is what that thing uses internally to do work, okay? And it's super fun to use and very fun to modify and change things and so on and so forth. Is really fun. So I've been tinkering with that. Also, I can use it with Olama and even have a local model running very easily. And I had some success, so I can run the full AI thing on my machine. Not that I want to, but it's possible. So I can literally use those things on a plane if I want to, which is something that I really wanted to achieve. So I had fun with that. Okay. Yeah, it's very easy. The other thing with talking with AI is Tailscale. If you're not using Tailscale is you're missing out. Okay. You can interconnect all your devices, servers, and so on and so forth in a single network. It's phenomenal. Okay. I'm a fan. So try that. And combination with those two together, I can more or less code things on the phone if I want to. And whenever I go, I can just have, check in on my agents doing things. And I'm becoming one of those people, apparently. So
the problem that I have right now, I know that a lot of people are running multiple agents at the same time. I'm having problems with that, multitasking between different tasks myself. So it's difficult for me to schedule enough agents to do things all the time in the background. I just, maybe it's a fault of my own as a manager or something. But the end result is that I often end up waiting for AI to finish something.
Yeah, which is, doesn't speed things up, essentially.
Well, yes and no, but yeah, it's kind of like going back to the early 2000s when we had slow compilers.
Yep, a little bit.
All right. Well, Matteo, if people want to continue to follow along with the things you're working on, where do they find it?
They find me on Twitter at Matteo Collina, or they can subscribe to my newsletter and at nodeland.dev. And yeah, that's kind of it.
Cool.
And of course, follow at Platformatic and contact us if you need any help. Very happy to chat.
Sounds good. All right.
Support the people who are making Node literally work.
Yep. Bye-bye,
All right.
folks.
Yeah, we'll go ahead and wrap up. Till next time,
Yay.
Max out.
Adios.